and the time difference with Japan is 6 hours, so it's too late for him to attend our seminar. And he asked me to ask the people who attend the seminar to move the seminar at least once in a while to some other time, like 2 p.m. most of the time on Thursday. We can move it to another day, on Thursday or on Friday, once in a while. Can we do this?
I'm okay.
Oh, okay. So we shall just choose the time and have him once in a while at our seminar on Friday, for instance. Okay.
Okay.
You can try.
Okay.
Friday not so good
Because
the
Friday,
lecture-
Thursday, okay, depends. Thursday, Friday, like you would say. Okay.
Oh, yeah.
Okay, let's start. In this talk, we will give some introduction on the most important results in this year's paper and our recent results around the Bayes conjecture.
Just a moment before you go on. We need to have microphone to talk via Zoom instead of via YouTube. But for Zoom, I need to turn on your microphone here and I will put it here. If you speak loudly, I hope Sasha, Sasha Saponov will hear you.
Oh, okay.
Павел, ты слышишь? Павел? Павел? Значит, если не слышно будет, ты скажи, я сделал микрофон.
Пока что все, что говорил, все слышат очень хорошо.
Окей, все.
Maybe I can say 2 words before talks of Junko.
Okay.
He,
Okay.
the talk of Junko is based on our recent preprint you can find in archive. And since our seminar, one of the aims of this seminar is to give the opportunity for students to make some reports on their work. This is the opportunity to present our work for Junko. And the questions are not directly connected with deformation quantization. Also has certain connections with it. And the theme about the Bayes conjecture, about the Dix-Meyer conjecture, and about the Bayes conjecture is related to my talks which I gave in the last semester and fall. So this is new results. This is a new result in this direction. And it's interesting because it's related to famous open conjecture in algebra. I hope Junko will explain it and will explain the details. But since the work is hardly based on the original work of Dix-Meyer, I think he will first explain the result from the Dix-Meyer paper, and then we'll continue with explanation of our result.
Okay, let's start. Sure. There are 2 parts in this talk. One is to present some important results from the Dix-Meyer paper, and it will help us to understand what our tool in the recent results. And our recent results have 2. The first result and the main result, I will explain them after. And before, we have to emphasize some basic definitions. Here, the first wheel algebra consists of 2 elements, x and d, and their D bracket is equal to 1. And here, the k, for convenient, we here can assume that k is an algebraic closed field. And for some convenient, if you maybe you can view k as the complex field as you like. And in Dix-Meyer's paper, he presents the automorphism of A1. This is generated by the can be generated by the term automorphism. Is phi n lambda.
Is conjecture, is it claim that all automorphisms are tamed?
Yeah. D to D and X to X and with and phi n lambda prime D to and phi A B C D. With the determinant A, B, C, D is equal to 1. And D.X. Mears present his famous conjecture in this paper is that all the endomorphism.
So what is the claim on automorphism? What is the claim?
Automorphism
Every automorphism has the form.
can be generated by this term of morphism. That is, for any phi in automorphism A1, it can be the composition of all of term automorphism.
This is the claim of Dix-Meyer conjecture.
No. This is another. This is the construction of the automorphism. The automorphism can be generated as the term automorphism. It can be written as the decomposition. This phi I is term automorphism, and the Dix-Meyer conjecture is that it's about the endomorphism of A1. If endomorphism is not equal to 0, Dix-Meyer thinks that it is an automorphism. This is the Dix-Meyer's conjecture. He thinks that the endomorphism, the non-zero endomorphism, is all automorphism. So before we consider this talk, we will introduce some interesting tools, some like the Newton polygon. For example, we give a if we give a polynomial with two elements, f, x, and y, then we can present all the points I and j in the picture of the axis, and all the points related to the Cij is not equal to 0. They will construct a polygon. This is called the Newton polygon. We can give an example how to construct a Newton polygon. If f is equal to 1 add with x, y, and 2x squared y, then we can see the Newton polygon is for 1 it is 0, 0. For here is 1, 1, because this here is 1, 1. For here is 2 and 1. Then we can point out all the points here and here and here. Then the Newton polygon of this polynomial is somehow like this.
So it's just convex hull of all points.
Yeah. This is a convex hull. And so there is for any polynomial f, we can define the EF as the set of the vertex of the Newton polygon. That EF is constructed by the all points ij. That Cij is not equal to 0. Actually, the vertex and for any real pairs sigma and rho, we can define the weight degree V sigma rho F is equal to the spring with sigma rho F is the weight degree related to the sigma and rho. For example, if we let sigma rho is equal to 0 and 1, then the weight degree is actually the degree of F in the of Y, and this is the actually and if sigma rho is equal to 1, 0, then the width rho sigma rho is equal to the degree of x in F. And if sigma in our paper in Dix-Mears paper and our paper, we somehow interested in the case when sigma rho are integer pairs. For example, if it is equal to 1 and 1, then the sigma rho is connected to this line with the sigma with this is with this line, we can talk about it.
So what is sigma rho?
Sigma rho are real number pairs.
Ah.
Yeah, we can choose it arbitrary for our convenience.
So V of sigma, what is
V sigma rho is just the weight.
It is also
Weight function associated with real
Yeah.
numbers.
with
ij then?
ij is I is the power of x, j is the power of y.
So I don't understand this.
Yeah, okay, I will.
Supremum is taken for all.
All pairs from
So sigma and rho are fixed.
yeah.
If we choose the fixed sigma rho, we can talk about v. But we can choose arbitrary sigma rho before we discuss the v.
It is a really weird construction.
Yeah, yes. We can. Yes, this is. Yes, this. We're now talking about the things in Dix-Mears paper, and this is the original definition.
Series of weight functions parameterized by real numbers.
Okay, here we construct ordinary differential operators from the first wheel algebra. That is sigma alpha ij x I square partial j square. Then we can do the same definition of p in EP and V sigma rho p for as the same like the before of f. So we can just totally the same, just related the x to x and y to d here. So in Dix-Mears paper, he present there is a lemma that's if P, Q,
Maybe should say that the annotations are Dixnier, but the usage of Newton polygon is not
yeah.
because Dixnier didn't write anything about Newton polygons.
Yeah.
I think the story is like this sequence, because the inventor of spectral sequence didn't try these pictures with sheets. But actually, he always thought about the spectral sequence in terms of these sheets. And I think the same is with Dixnier. In his paper, he has never mind about Newton's polygons. In fact, every algebraist who worked with his paper knew that people use these Newton polygons to improve the explanation of his paper.
Yes, that's right. The Newton polygon is not in the Dixmier's paper, but we will use the Newton polygon to make all the lemma and the theorem in Dixmier papers more visible. So if P and Q is in A1, then we can say that F sigma rho PQ is equal to F sigma rho P multiply with F sigma rho Q, and then with sigma rho PQ is equal to with sigma rho P add with sigma rho Q, and this we can see that if the Newton polygon of just we say that this is a sigma rho line, and the V sigma is just such how to say it? If the Newton polygon is contained in this line and there are vertex here, so it actually this line we call it as the top line of the Newton polygon, and the V is equal to this line's equation of the just with sigma x add with rho y is equal to V sigma rho P. This is called the top line of this. We can, if we use these notions of the top line, we can view this more visible, and as like if we draw the pictures of Q, these two lines are parallel, and maybe I draw it. So this is for Q, and this is the sigma rho line for Q, and there. Is there any much more stronger one? Do you have some longer one of this? Do we have?
This one is.
Oh, okay. Okay.
I think we forgot to introduce F of sigma.
What's the definition of F sigma?
If,
No such definition.
oh, so sorry, I forgot. I forgot the definition of. We can talk about this first. If we can see the V sigma rho is just the constant of the Newton polygon of this line related to the sigma rho, and if we define F sigma rho is equal to what's it? F sigma rho. Here we define the f sigma rho is equal to the homogeneous polynomials associated to the sigma and rho is equal to x I square y j square with Cij with, oh sorry, we have, we have to define another things before that. Here we should, I just cut. Yeah, yes. We have to define the set of EF sigma rho is equal to the points that is equal to sigma I add with rho j. Here we just this is the homogeneous points in the sigma rho line. Just if we see that in this picture, and this is in this picture sigma is equal to 1 and rho is equal to 1, then the lines like that. So the EF sigma rho is equal to this points in the Newton polygon, and this such as the points in the F such that the supreme can reach to the F. So, and we define the sigma rho homogeneous polynomial F sigma rho P is equal. Sorry, here we should use F.
All points or just points in E of F?
Yes, in E of F. Yeah, in EF such that the V sigma rho F reached. So F sigma rho of F is equal to the sum of Cij Ij is in E F sigma rho x I power y j power. So F sigma rho F is just cancel out the terms that they didn't reach the weight degree, and then we call this F as the homogeneous polynomial.
So what is Cij?
Cij here is in the definitions. We just cancel out the terms that they didn't reach the weight degree, as we define the weight degree as the supreme. Then there are some terms they didn't reach this degree, so we cancel them out. And for example, in this paper, here F is equal to.
Just give the terms on which supremum is not reached.
Yeah. We can see that this term 1 and this term x and xy, they didn't reach the V sigma rho of F is equal to 3. They didn't reach the weight degree 3, so we cancel the 2 out and only get P to be the sigma rho homogeneous polynomial of F. Is that so? F sigma rho F is equal to P, as we call the homogeneous polynomial. And there is a lemma said that if now we use the same notions of the ordinary differential operators, the same like the definitions of F. the all P and the E P sigma rho is just all the same. So there is the lemma said that if the production of two ordinary differential operators, their highest terms is only constructed by the highest terms of each element in P and Q. Say that F sigma rho PQ is equal to F sigma rho P and multiply with F sigma rho Q. And their weight degree is equal to the sum of sigma and rho. For example, we can see that if sigma rho is equal to 0, 1, then they becomes like the rules of the integral domains as degree y of PQ. Importantly, here is should D is equal to degree D P add with degree D of Q. Then, and for others, it's the same, and they can just use the highest term to calculate their weight degree.
This is degree from this nearby.
Yeah. And it's not so difficult, but we omit the details, and we can continue on. If we want to construct the Lie bracket, we can see it from the same calculations. If R is equal to the Lie bracket of PQ, and we assume that P is equal to sigma alpha ij is I squared and J squared. We have to say that if Q is equal to, if R is equal to the Lie bracket of PQ, then the H is not the simply calculation of F and G, because the first Weyl algebra, if we want to calculate this, it's very chaos, because it's not directly equal to x I add with L, and there are too much terms after that. So we use the weight degree to see it more convenient, as they are not equal to each other. So we can calculate it on the H is equal to partial F and add with. Yeah, we just calculate the mixed terms of them. Actually, the definition. Yeah, actually, we can see that the calculation of this shows that the first term is actually the Poisson bracket of the f and g, and if I remember right, maybe the latest terms are some extra Poisson bracket, but I don't know. But the first term is just the standard Poisson bracket of f and g, and what we most considered the terms is the first the Poisson bracket, and we can see if we can we assume the V sigma rho of f and the V sigma rho of g, and if we want to calculate the weight degree of h related to the sigma and rho, then this term has the weight degree V sigma rho f add with V sigma rho g minus with rho and minus with sigma, and this terms has the V sigma rho f. Just so I'll and this term has the weight degree of 3 sigma and 3 rho. So we can calculate it by the weight degree from the big to the least. And after that, we can see there is a important lemma in the Dix-Mears paper. What? We just, as we defined before, the weight degree of f. Just the sigma rho is an arbitrary real number pairs in R. Just the same sigma rho as we notion before. Yeah, we will always use the notion of sigma rho. Yeah. After choose the sigma rho, we should fix them.
It's strange that you have even degrees here, because if you just take, for instance, it looks like actually the thing you obtained from model product. In model product, all terms with even degrees of formal parameter, they are symmetric. That is to say, f b of f g is equal to b of gf, right? It's like they have the same, they're commutative, so to say. So when you take commutator, these terms just disappear.
Yeah.
And in your case, you have, it seems that you have even terms here. The second term is even. It's strange, really strange.
And f small g and h is just polynomials where di changed by y.
What?
F, g, and h is polynomial where
G is take change. Just
change the d by
y
by y.
and x by x. Just here x and y is just L is the K-free model. It just this is from K. This is a free model. Okay, and just take the place replaced by them, and the coefficient is yeah. after that we get this result. And from this result we can get an important lemma in Dix-Mears paper, and we will use it after. We just point out it's 2.7 in Dix-Mears paper, and here if PQ in A1, then sigma rho are real pairs, but here we should let them have the properties that sigma at with rho is more than 0, and V is equal to V sigma rho P, and W is equal to V sigma rho Q. And we suppose that F1 G1 is a homogeneous one polynomial related to P and Q. Just F1 is equal to the homogeneous one to P, and G1 is equal to the related to the homogeneous polynomial associated to the sigma rho of Q. And after that we can say that then we have there is T and U such that we can see that from this, we just calculate the Lie bracket of P and Q. And if we assume that rho plus sigma is more than 0, then we can get this definition. We can choose the terms of the Lie bracket of P and Q is equal to T add with U. The actually,
Write out loud this formula, because it's this theorem. So any P and Q in whatever, right?
yeah.
And any rho and sigma such that their sum is greater than 0. If you consider the weights of P and Q, and we suppose that F1 and G1 are homogeneous parts with respect
Yeah.
right? Then there exists T
And U.
and U in A1 such that it's very long, so V sigma rho of U is less than V plus W
Yeah, we can see from
minus sigma rho. E of T, what is E of T?
the
Oh yes, it is just E of T sigma rho, right?
yeah, T is
E of
sigma rho homogeneous.
T is homogeneous.
Alright, it's homogeneous. And what is TF? The following are equivalent.
Okay, that's the following of equivalent.
T is equal to 0. F and Fi and G. What is Fi and G?
F1
Can
It's
we-
homogeneous. Well, I assume at the homogeneous. F1 is homogeneous related to the P, and G1 is homogeneous terms related to the Q.
Okay, yeah, so we Poisson commute.
Yeah.
And number 3 is what is
If V and W is integer,
are integers. Okay, G? What is GV1?
V is equal to V.
G to the
G1
power
is the homogeneous terms.
equal to lambda.
Some this lambda is some coefficients in K. And the third one is that if T is not equal to 0, and then T is just the homogeneous terms of the Lie bracket of P of Q. We can see it on this as the calculation before, that we have the
And what is about U? It didn't say anything about U.
Yeah.
U is a number
U is just the terms that didn't reach the degree of V at W minus sigma 0. Yeah, we can see from this, with these calculations, actually we want to separate the important part and the less important part. The most important part is just the Poisson bracket of the F and G. And the less important part is the following part. They doesn't help much in the research, but there are too many of them. So we should cancel out the not important terms. So we point out the most important terms T as the homogeneous terms of the Lie bracket of P and Q. It's just if the T is if the Poisson bracket, the first one is not equal to 0, then T is not equal to 0, then we should point out the Poisson bracket as the homogeneous terms of the Lie bracket. If they are equal to 0, then T equal to 0 is equivalent to the Poisson bracket of the homogeneous polynomial is equal to 0. So if T is not equal to 0, then T must be the homogeneous polynomial related to the Lie bracket of P and Q. So as like this. So from the calculation of this, we can view this lemma somehow clearly, and we can see it on the. We can see it on the from the Newton polygon.
Continue, I just comment. There is one interesting question proposed on this translation in Europe. It says that automotive M3 algebra is, I don't know, simply can then go to our guys announced the proof of this conjecture about 2 years ago, but I am not sure, I'm still not sure that there are no gaps, so I have seen just two parts of the paper was published, but the third part was not yet published.
Do you have some questions?
Just about this comment. So you have two algebras, one Poisson algebra is the usual Poisson grid. And the n-squared algebra, the algebra of differential operators in n variables with coefficients in polynomials. They conjecture that the homomorphism rule of the n-squared algebra is isomorphic to the symplectomorphic, to the rule of symplectomorphism in the Poisson algebra. This is their conjecture. Because their algebra is a quantization of Poisson algebra. They suppose that there is an isomorphism between homomorphism group and the group that resolves the Poisson. The conjecture was still open, but they announced the group 2 years ago. But still, I'm not sure that it's checked somehow. The big higher or not higher. Conjecture can be looked at the group by estimating the group and other forces.
Okay, we can see an example of this lemma. If P and Q, the Newton polygon of them shape like this, and we here assume that sigma is equal to 1 and rho is equal to 1, then if P has the coefficients of somehow like this, and it has a coefficient like this, that is, if F1 is equal to x3 squared and with then we can from this we can see that they didn't have power related to each other because they cannot divide it by each of them. So, and we can see that the Poisson bracket of F1 and G1 is not equal to 0. So here we can see that the Lie bracket of P and Q just has the weight degree reached to the sigma rho. Sorry. In this,
this claim actually says that if we take a top degree part, if we just take these homogeneous parts of P and Q, and they will be somehow proportional when you raise them to the powers.
yes.
Just wonder how this can be proved, because
Yeah.
it's probably the most subtle part of the whole. All the rest I can somehow imagine the proof, but this
Yeah.
I'm totally lost.
In this, we can see that there didn't exist lambda such that F1 V square is equal to G1. Sorry, W square is. Here the F1's W square is not equal to the multiple of G1's V square. So, but if we change the coefficient of F1, just say that if here is 3 and we just wipe them out at 3 here, then in this time the Poisson bracket of F1 and G1 is equal to 0. So here the equivalent doesn't it disappears and it becomes less than. So this is an example of this lemma. We can continue. There are another notations in Mears paper, which is used in the future. I will explain. Here we assume that A is an algebra related to K, and P in A. We denote as CP A is the element in A, such that PQ is equal to QP. This is the element in A which commute with P, and this is a very easy part. And if we we can centralizer, yes. If we define the Vy is equal, sorry, it's not Y, Vq is equal to, we choose another element, Q in A12. Vq is equal to sigma. The K is in big K. We define the notation of VQ is just the multiple Lie bracket from the derivative of P to Q. And we define the set F X, sorry, it's not X. P of A is equal to, is the elements Q such that Q in A1 such that dimension we just say that the Fp of A is the elements Q in A1 such that if we view VQ as a vector space, the dimension of the VQ is less than infinity. So this is a definition of the Fp of A. And this if we consider this Fp of A in the first real algebra, it will be much more, there will have some qualities. But before that, we should define the notion of D. We define just for PQ as above, and we define dP lambda is equal to, sorry, not 1, Q in A such that AD. We define the notion. Yeah.
Q is just commutator, yes?
Just elements in arbitrary algebra A. Add is the derivative of Lie bracket. Just we can say that just that AdP of Q is equal to the Lie bracket. This can be done on arbitrary algebra. And we define the dP lambda is that all the elements in A such that lambda is the eigenvalue of the derivative of P. And we can see we can see that the centralizer of P in A is we can short this just as C of P if there is no problem with A is equal to dP0, because when lambda is equal to 0, AdP of Q is equal to 0 means that P of Q is commute with each other. So we can see that the centralizer of P is equal to the case when lambda is equal to 0. And we can define the nilpotent set of, and we define n of P in A is equal to we define the nilpotent set of A is just that all the elements in A such that we can do multiple nil bracket P of Q such that finally the Q equal to 0. This is the nilpotent set of P n, and we combine these three. We can combine these three parts of the separate part of the A, and we can now this is for the arbitrary algebra, especially for we can view A as A1 now, and this is also worked in A1. The definition in A1 is just all the same. So in Dix Mears paper, there's a result that.
Sorry, what's the difference between this n and what is the difference between these bases?
What?
So you have FPA.
Yeah, he will write it just now. He will write the connection between spaces.
Yeah. Well, I will write them together.
Looks like more the same.
No, they are not the same. They are different. Because I just mentioned that in the arbitrary algebra, and I will collect.
So some connection, right?
Yes. We now assume that the algebra is A is equal to A1. We can write them together. Fp is equal to with the sum of Q such that there exists n. And we can see that the F is the biggest set, and D of P and N of P is just some special case of F. Is that there F is that just the way there x n such that AdP minus lambda's n power makes Q equal to 0, and dP is just.
The second equality is obvious just from the definition, right?
Yes. It's just the definition.
And what about the first one?
first one is also from the definition.
It follows from the definition. That's just result
The-
of
the-
yeah.
It's just that we can see that from the original definition, it is VQ is that sorry. Sorry. FP that the dimension VQ is finite, and the VQ, the definition is the sum of K A D. And we can see that there is some easy calculation shows that FP is just in the form of this.
So the Q is the vector space of such sums, or only one sum? And
What?
The sum is taken over all lambdas and all q's or what?
Yeah.
it's the set of all such sums, or it's just
Yeah.
one sum?
VQ is a set of all the sum, and the FP is the collection of Q that the vector. If we view VQ as a vector space, then its dimension is finite.
It's not just a linear square, it's just the set of all q's for which this
Vector space has finite dimension. Yes.
And that means that precisely that we have this relation. That's
Yeah.
the other standard spec.
Yeah. So.
Do you assume, just one question, do you assume that your vector ground field is algebraically closed?
Yeah. Well,
So it's
we just in this talk, for convenience, you can always view K as the complex field, all right?
algebraically closed.
Yeah.
But just for this talk, it's not necessary in general.
Yeah. Because in the original,
Ну, более-менее, да. Так можно.
in Dick Smear's paper, he used the tensor product to discuss the. Sorry.
What is the dimension of formal sum?
Huh?
What is the dimension of formal sum?
What dimension of what?
So you're right, VQ is sum over n.
Yeah. If we can just view them as the vector space, just forget the.
It's a formal sum.
Yeah.
The set of all this.
But this is the sum is taken inside the wild algebra.
Yeah.
Yeah.
It's not formal. It's just
Infinite-dimensional
subspace.
vector space,
It's
but-
potentially infinite dimensional vector space inside wild algebra.
Yeah.
It's just
Нет, просто с-
написано, на самом деле должно написано линейно рабочее. Это множество таких сумм.
Нет, ну, сумму пространства.
Yeah.
Вы полагаете, да, линейное пространство, просто видите, что там именно неформально, поэтому написано сумма. То есть, что вы можете брать в конечной линейной комбинации сложения. Если бы там она была формальной, можно было бы там брать бесконечные суммы. Но это именно просто линейная оболочка. Но она может быть бесконечно неверной.
Yeah, in Dick Smear's paper, if K is not an algebraically closed field, then there will be a lot of notion like this. So we make it more visible to view just K as the complex field or some algebraically closed field to make it some visible. Yeah. And we take back look of this FP and DP and NP and CP. We just will that it's easy to find that DP and NP is the subset of FP, and the CP is just the intersect of the DP and NP. And in Dick Smear's paper, he proved that in the first Weyl algebra, the FP, it seems that MP is more bigger than DP and NP, but we have the results of. Um,
This is important.
yes, this.
Result.
Yeah. In the first wheel algebra, that is whether dp is equal to fp and or np is equal to fp. So that the sets fp is not much bigger than we can imagine. And after that, we can discuss another important theorem that is helpful for.
I think you can erase this
Yeah,
number
right.
27 because
Yeah.
otherwise people will forget.
Okay, okay.
And this thing is important because the proof of this theorem, about the homomorphism group is based on this fact.
Собственный вектор, конечно, допустим, это центральная линия от этой части.
Ну да, если он у него степень размер собственных пространств,
Одномерно.
This is another important lemma in Dingsmir's paper. That's sigma rho are integers. Here we assume that the integers and v is more than sigma at with rho, and f is not a polynomial. F and q is sigma rho homogeneous associated to p and q, and f is not a monomial. That one of these a, b, c, d will exist. And that the first one is that f w square and g v square are proportional to each other. According to the since we get before is equivalent to Fg's Poisson bracket is equal to 0. And if sigma is more than rho, and the second is BCD is the relation between sigma and rho and the shape of F. If sigma is more than rho, then sigma must be divided by rho. And Fxy is equal to lambda x alpha square and blah blah blah. And if sigma is less than rho, then rho must be divided by sigma, and the Fxy has a form of like that. And if sigma is equal to rho, then Fxy has a form like that. And here alpha beta is just some integers more than no less than 0. And there is another maybe I should wipe this.
I'm sorry. And what about the case when sigma and rho are not proportional to each other?
Sigma. No, this is important. This is the result.
So it's not the case.
I think the claim is that this is one of the possibilities.
Yeah. Yeah, one.
Either they are proportional.
No, not neither. A and B they can work together.
At least one of the proportions.
Yeah. At least one of them will exist.
Yeah. D. I think sigma is greater than rho. Then sigma divides rho.
Yeah, this is the claim, but it cannot not divide it.
I think there should be what do you call this? The corollary.
7.4.
The power of it, that sigma must divide rho.
Does it fall from the положение?
Yeah. Something one of the, at least one of these should fall.
But the assumptions are higher. We have to believe that sigma is one integers, and that the order is greater than sigma plus one. Very weak assumption, actually. Because many cases.
Here we should say that the proportional the relation between sigma rho is important, as we can get this lemma from Dick Smith's paper 7.4 that if F has have such rules that weigh more than sigma plus rho, and it's like there, and F is not a monomial, and if sigma and rho has no relation like B, C, D, just they can be divided by each other, or they are just equal, then the Fp is equal to Cp. And we can see before that Fp is a very, very much big set, but if this all items is satisfied, then Fp is just equal to the centralizer of P. And this is since in Dick Smith's paper, we can draw a picture to take a look at the terms of B, C, and D. You can draw a picture to see like that. This is for, sorry. We should write here. This is for B, and this is for C, and this is for D. We can see the shape of B is somehow like the Newton polygon of P must shape like this one. If alpha is more than 0, we can see that we can't reach the point of here in the Newton polygon of F. F is related to F, that it just can reach here, but this cannot be reached in the case when alpha is.
The top vertex of this triangle?
Yeah. We can't reach this vertex in the triangle, and the Newton polygon must strictly less than this line. And if in the case that alpha is equal to 0, then if alpha is equal to 0, then the triangle is full contained in of the Newton polygon. And in the case of C, here the triangle, and in this the line is more vertical. I should draw it more vertical, like this, somehow like this one. And here is more flat.
So
The Newton polygon.
The formula on the right in the parts B, C, and D.
Yes.
This H is polynomial.
Yes, the shape of the F.
There will be only 3 monomials in this.
Yeah.
Only 2 monomials, sorry.
3.
2.
Yeah.
Just if we open all the brackets, we will get. Oh, sorry, no. This is power beta. I don't see it.
Yeah. It can. The vertex cannot reach here. It must be cancelled down here. This is the case when alpha is more than 0. I should draw it much more bigger. The vertex here, we cannot reach it. It must, the Newton polygon must shape like this. Yeah, the Newton polygon must shape like this, and it will be more visible if I can use a lot of corners, but here there are only 2 corners, so it becomes somehow not visible. And if alpha is equal to 0, if alpha is equal to 0, the Newton polygon of P is somehow like this. And for the case of D, this is the sigma rho line related. In the case D, then sigma is equal to rho, and we can assume that they are equal to 1. So, and the points here, maybe it is, this is alpha not equal to 0 and beta not equal to 0. And we can maybe it's like somehow 1, 4, 5, 2, and it's construct like x. it's the coefficient of this polynomial. And if alpha is equal to 0, beta not equal to 0, or alpha not equal to 0, beta equal to 0, then the Newton polygon must shaped like 1, 3, 3, 1 or others. And
So what's the difference between these coefficients? I don't see any difference.
yes, this is they have different terms, and this is
Yeah, but the picture is pretty much the same. Pictures are pretty much the same.
they are somehow same, but they are a little
Oh,
different
because
from
the coefficients, the
Yeah.
numbers that appear are different.
yes. It's just an example. So, and this is all the things of the Dix-Mears paper, and our
I'm sorry, could you erase this? Yes.
yeah, okay. Our recent results is related to the Beerist conjecture. Yeah, the Beerist conjecture is said about the if f is an equation that just as before. And Cij is in the complex field such that the solution is a Riemann surface, and if it has the genus of G is equal to 1 or G more than 1. If G is equal to 1, then the number of the solution orbits is finite. Sorry, sorry, I put it wrong.
What is solution? Solution to what?
Solution of this equation, fxy is equal to
In A1.
In A1.
in A1, yeah.
The Riemann surface is given by this equation, yes, and what is solution orbits?
I mean, you just
You will see.
Yeah. I didn't write the definition of the solution orbits. Yeah. If the number of the solution orbits, if G is equal to 1, the number of the solution orbits is infinite, and if G is more than 1, then solution orbits is finite. And
with respect to what?
we write the orbits is equal to the O sorry, phi. Phi p of q. Yeah. The solution orbits is defined as the all possible pairs of phi p of q, and phi is the automorphism of A1. Because in Dixmier's paper we can oh yeah. Oh, if PQ is equal to 0. Yeah, PQ is the solution of the F, and
I also presume that you have to write down f of x and y in a fixed form, so that the x is always before y.
Yeah.
Otherwise, this substitution is not well defined.
Okay.
We can make them choose such a form. Actually, it's not important, but yes, this fixed, the polynomial is fixed.
Yeah. Yes, the solution orbits is all possible p of phi p of q of all automorphism phi. It's easy to see that if p and q is the solutions of the equation, then phi p and then it's easy to see that because phi is an automorphism. So this is a Bayes conjecture, and our two new results is related to this Bayes conjecture. The first result is that the solutions of this equation, if xy is equal to 0, the solutions p, if p and q is the solutions to this equation, then p and q is commute. And the second result in our paper is that
Just didn't understand this. Wasn't it known that if p and q...
I write them after. I just if p and q is a solution to this equation, then p and q commutes with each other. If okay. And our second result is that if there exists an equation fxy is equal to 0, such that the solution orbit is finite, then the Dixmier conjecture works. Works, yes. And I will write.
I'm sorry, can you explain once again what is OQ, what is this set?
Oh, OPQ is the solutions orbits if just all possible. Sorry. It's all all pairs of phi p of q.
What do you mean?
Just all possible pairs. Maybe it's somehow like P1, and P2, Q2, blah blah blah. It's a set of pairs.
Okay.
Okay.
And then you play fight. What?
Yeah?
Вы берете алгебру Вейга, берете пару ПК, применяете, если это удовлетворяет уравнение, то и для любого автоматизма тоже эта пара будет получена этому автоматизму.
Yeah. Any equation will have many orbits of many solution orbits. The number of the solutions orbits may be finite or it's maybe infinite. We have if the solution orbits is finite, then Dix-Meir conjecture works. Yeah, there are two results in our recent papers. Is that if f is a polynomial and such that fpq is equal to 0, then pq commutes. And the next one is that if there exists a polynomial f such that the number of the solution orbits is finite, then the Dix-Meir conjecture is true. And actually, I have to explain that for the first one, there is the Blanchardi course lemma says that if PQ commutes, then there exists such f such that fpq is equal to 0. And this results just the inverse of the Blanchardi course lemma. And so, and I think the time is limited. Yeah.
There's some explanation how it's
just maybe briefly, just many steps of the proof.
Okay. Just then we omit. We only show the some main step of the second result. The best conjecture says all the.
make no claim about the genus of the corresponding.
Yes. This is the fact this claim is stronger than just the implication from various conjectures to its mechanism. Just enough to find one.
We can say that if the we can say that if the base conjecture is true, there exists some G more than one, then Dix-Meir conjecture is true. But we don't need it is too stronger. We just find if there exists one polynomial f, then the Dix-Meer conjecture is true. We don't need all of them is finite. Just one is finite is enough. And we shall say that we change them in some to this. For the first one is that we should transfer if we can for the automorphism of the first Weyl algebra is it must has a Newton polygon shaped like the triangle. The the Newton polygon of the automorphism must shape like a triangle. But if we propose a lemma such that we have a lemma that transfer an endomorphism into we say that rectangular type. That whether phi is an automorphism or there exists an automorphism such that phi circle composition with phi is rectangular type. I can show that this is automorphism. This is in Dix-Meer's results.
It's corollary.
It's easy to see what from the decomposition of the automorphism into term of automorphism. And this is the rectangular type. The Newton polygon, we can change any arbitrary endomorphism into a rectangle, such like that. This is our first step, and our next step is. Our next step is from, as we know that.
You forgot to write that it's a Newton polygon of psi of g.
Yeah. Oh yeah. Okay. Yeah, this is Newton polygon of phi tilde of d is equal to the composition of phi and the automorphism phi. The next step. Our next step is from the. We know that the solutions, the number of the solutions orbits is finite. Then we can, but the integer number is infinite. So we can do some. We can transfer. We can do the phi of multiple times phi just q. It will come back to the orbit is finite. So after some acts, it will come back to the original orbit, because it's finite and the integer number is infinite. Will they will in the same orbit because the solution orbit is finite. Then we can use these properties. We can do some change that, if I remember, it is phi 2 tilde is equal to some psi inverse with phi. We can do some transform like this. We will have that, and p prime is equal to, sorry, it's somehow like C inverse here. Sorry. If we do this transformation, and we will finally get that phi 2 tilde is equal to the p is a fixed point of phi, and this will do helps to our final calculations. This is the next step, that we find a fixed point for phi. Each time we do this transformation, we always use the automorphism, so that it didn't change the properties of endomorphism.
You forgot to write down what is psi.
Yeah, psi. Yeah.
Just write.
Just here where I should use this. Here, because according to the definition of the solution orbit, if they are in the same solution orbit, then there exists automorphism phi psi to transform it into it. This is the definition of the solution orbit. Then after some transformation like this, we'll have that p 2 tilde is the fixed point of the phi 2 tilde. And the third step, is that we can calculate the third step is some much. The third step is that we can do the knee bracket phi q times square d to p. We can do this knee bracket for many times, and we we can do this knee bracket for very more times until it become the homogeneous polynomial of it becomes a monomial.
It's possible.
Yes, it's possible.
How would you prove that? Certain element.
Yes, this is easy to explain because we can have that AD. Sorry. Yeah, we can. If n is bigger enough, then it will become 0. And phi is an automorphism, so we can apply phi here. And p is the fixed point. So p didn't change, and we have, if n is big enough, then it becomes 0.
Mutate actually because it's the degrees, right? So
Yeah.
just to know anything.
Yeah, because the original one is.
One step before it should be monomial, right?
Yeah. So we can assume that MQ is the first one, such that f sigma rho AD blah 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 is a monomial. That, and after we assume that, we can calculate the properties of MQ. We can assume that for some P2. Actually, yes.
Explain them in time actually, because when we change this endomorphisms, we need to control this shape of the Newton polygon.
Yeah.
And it's important. Also, these calculations are important because this iteration of Poisson brackets will kill the monomials of the homogeneous polynomial step by step. And the contradiction lies inside these calculations. So if you like, you can continue that.
Okay.
Just the idea is that
Yeah.
apply these calculations.
We can, after we assume that the definition of M is equal to MP and MQ. We will get the relation between M and the V sigma rho P. It doesn't depend on other things. It just that we can get this relation between V sigma rho P and with M. Oh, by the way, the sigma and rho is related. The sigma rho is related to the rate of phi partial and phi x. Sigma rho is related to some relation between this, and I omit them. Just to say that a sigma and rho is fixed here is okay. And we can say that if sigma rho is fixed, then the relation works, and it doesn't depend on the P and Q here. So we will get.
We didn't speak about Q.
Yeah.
Q
P
is
is a
just
stable point, right? And what is Q?
Q is some.
Q is the second. Q is so P is a fixed point, and Q is the corresponding counterpart.
yes.
Is some.
Okay.
We can just omit it. But if we assume out this M, and it will becomes get this. We will get this equation. And if we assume that, we can also assume for another. Also, we can assume that. Oh, sorry. Oh, sorry. I said it wrong. MQ is the number such that the monomial is almost commute with phi is commute with key, but I have no time to explain for that. But MQ, this is the first monomial. Almost commute to this one, and NQ is assumed to be the first one, such that it becomes a monomial. But after our calculations, we will get that n is equal to m. And after that, we can do some calculations, some specific calculations of the multiple Poisson bracket. We will find n cannot equal to m. It cannot be, once it becomes a monomial, it cannot almost commute with phi d. Then there is a contradiction. There is a contradiction. So the detail, it's a very technical work. So that's all of today. Thank you.
Okay, thank you.
If you are interested in the details, вершина вот этого треугольника была. Дальше там вводится важная вторая характеристика идоморфизма прямоугольного типа, там эпсилон. Это коэффициент пропорциональной мотеции между вот этими прямоугольниками у оператора d и оператора t. И вот эти угловые в конце, они не просто так берутся, а они берутся какими-то равносильными, чтобы их отношение было равно этому пропорционально. И тогда можно получать
Oh, okay, okay. Sorry. Where should I put it?